In the last video, we solved the differential equation y prime equals y over x plus x squared with the initial value that y at 1 equals 2. So now what we're going to do is we're going to go ahead and plot the direction field for the differential. Then we're also going to plot the particular solution on that direction field. And you probably remember from the last video, this was the code, all right? And it yielded this solution. And so that's the most important part, is just to get the particular solution. The rest of this stuff I don't really need except for the solution. All right, so now what we're going to do is let's do a CLC, or let's just clear all. So that way, if I wanted to, I can just go ahead and keep whatever I have. And I'm going to define a Sims variable, and I'm going to make it capital X. All right, so keep that in mind that this is a capital for a reason, okay? Which is going to be different than lowercase x. I'm going to define this thing called a mesh grid. It's essentially going to be an area. So I'm going to say x comma y, and I'm going to define the range of values for my direction field. So bracket xy, I'm going to say that's going to be equal to mesh grid, right? And notice our initial value is 1, 2, so like around the 0.21. So let's do this. Let's go -1 colon, and I'm going to use 0.2 colon 3. And I could resize this if it doesn't look that good. And then -1 colon 0.02 colon, or 0.2, excuse me, colon 3. All right. And again, if we don't like that, we can change it. All right. I'm going to suppress that. Now what I'm going to do is I'm going to enter the differential equation. I'm going to call that y prime. And remember, the differential was y over x, okay? But now we're using a vector, all right? So I'm going to say, because of this mesh grid, so we're going to say y dot over x plus x dot squared. I'm going to suppress that. So that's our differential. I'm going to have to plot the angles for each of the vectors or the slopes that we're going to go through and plot. So I'm going to say theta is going to be equal to a tan of our y prime. Then I'm going to get an x and a y coordinate. So I'm going to say u equals cos of theta. And I'm going to say y, or I'm sorry, v is equal to the sine of theta. All right, and remember, the x and the y coordinates in trigonometry are the cos and the sine. So I'm just taking, basically, this is the x and the y coordinate, and the arctan is giving us the inverse of the original differential. Okay, so remember, tan is y over x, so we're just finding it that way. Okay, all right, so now I'm going to go ahead and plot the solution. Okay, so remember our solution was right here, okay? Except what I'm going to do is I'm going to replace this with the capital X, okay? So this was our solution, okay? And I don't need the dots for this, okay? So that's the solution to the DE, okay? And then we found in a previous example, okay? So essentially, you would have to run this first to be able to get to the solution. Okay. All right. So at this point, now we can go ahead and use one more function. I'm going to call that quiver. And quiver is going to be x comma y comma u comma v. All right. Now I'm just going to run this just to illustrate what's going to happen with this. All right. So I run it. All right, so we get our differential, and here comes our slope field. Okay. So this is our slope field that we've produced. Now we haven't plotted the function on there, okay, but at least we can get the slope field. So this code right here, starting with the mesh grid, okay, and then excluding this. So these 5 lines that I have highlighted along with the quiver are going to give us the slope field. Again, if I wanted to change the window, so for instance, maybe I want to start at -3 and then go out to 3, okay, I could run this again and get a different window. And so it's running, and then just give it a minute. But notice that the further you go out, the less precise that your vector field or your slope field is going to be. All right, so I'm just going to go ahead and go back to -1 for both of these. And again, once we get the particular solution plotted, then we can go ahead and do the rest of this, okay? So now let's go ahead and plot the particular solution on this slope field, okay? So when we do that, what I'm going to do is I'm just going to easy plot. I'm going to do a hold on because I'm going to plot this on the vector field. So I'm going to plot, and I'm actually going to do an easy plot because it's nice and easy, no pun intended. I'm going to easy plot the solution, okay? And remember, we had our solution was f. So I'm going to easy plot f. And undoubtedly, I'm going to try to keep the same window from -1 to 3. All right, so when you do this, you might have to play around with the window, but if you change this mesh grid, you should probably change the easy plot as well. All right, and certainly I could label this. All right, so I'm going to do a title, and I'm going to say slope field for y prime equals y over x plus x squared. And notice that it doesn't like that because of the y prime. So let's just change that to dy dx. All right, just for convenience. All right, and it should be a square. All right, and then we have an x label. I'll just call that x-axis. And then I'll just copy this. And I'm going to call that the y-axis, surprisingly. All right, and then I can turn my hold off. Okay. And it's the slope field, and technically, and solution at the point 1, 2. All right. And let me bump this over just a little bit so we can see it all. Okay, so let's run it and see what happens. See if we can get to our solution plotted on the curve. So here's our solution. And again, that was the code from the previous video, nothing different there. All right. And then we get this thing. All right, so the window is a little bit off for us. Okay, so maybe what I want, but notice that the function goes from 1 to 3. All right, so maybe to stay within the bounds, maybe what I want to do is I just want to plot the function from maybe like, I don't know, 0.5 to 1.5 or something like that. So let's change it here. Okay, so 0.5 to 1.5. All right, just because this function gets really big really quickly. All right, so let's run it and see if that changes the window a little bit. And again, all I did was I just kind of looked within here. All right, so that looks a lot better. And certainly it looks like it's going around. And we could go ahead and just drag this if we wanted to. All right. Let me just change this one last time. Let's see if I do this from like 0 or maybe even like, well, -1 was pretty small. Let's say -0.5 to 1.5. Let's see if that makes it any better. All right, so again, all you're doing is you're just playing around with the window a little bit just to make it so that you can get a better picture of this. All right, so that's not too bad. You can see the slope field, you can see the curve going through it. All right, maybe I can just change this to 1. All right, although at this point, it doesn't really matter too much. All right. All right, that's not too bad. All right, so that's a pretty good indication of what the slope field would look like. So again, you might have to change some of these domains right here for the mesh grid, as well as this input right here. But overall, it should work pretty well. And it's certainly better than trying to plot it by hand, okay? And again, you can just drag this a little bit. So all I did was I just kind of clicked on it, and I'm just dragging it so you can kind of see the vector field at work. Okay, so that's how we go through and try to solve differential equations, and then also how we can plot the slope field as well as that particular solution on the slope field.